Welcome to our next example under the idea of limit. I have the limit as x tends to 1. I'm given s cubed minus 1 all over x squared minus 1. What comes to mind? What I'm seeing here, if I put x as 1, of course my answer becomes 0. Why? Because 1 cube is 1. 1 minus 1 gives you 0. Also, if I put x as 1 here, 1 square gives you 1. 1 minus 1 gives you 0. Obviously, using the direct substitution, I'll have 0 as my answer. I now have to what there? Improvise. What alternative method will work here? I'm saying something here. I can sense difference of 2 cubed and difference of 2 squares. Please note something. Please note that if I have a cube minus b cube, it is called difference of 2 cube. This man gives you a minus b into a squared plus ab plus b squared. All right, that is your expression for difference of. So if I multiply this and this together, I will have this expression. Also, if I have a cube plus b cube, this man gives you a plus b into a square minus ab minus what there? B square. Also, we have the sum of 2 cube. This is your expression. Similarly, if I have a squared minus b squared, this man gives you a plus b into a minus b. These are basic things you need to know, like often, like without taking your book or checking anything. You should know this. It should be on your head, right? So like you should have it on your memory. These 3 things here. So in this case here, I can see s cubed minus this one can still be expressed as 1 cube because 1 cube is still 1. So more like this one here gives you idea of what? Difference of 2 cube. This one here gives you idea of what? Difference of 2 square. S square minus what? If I put this one as 1 square is still this 1. So I'm saying that if I have s cubed minus 1, this top here can still be written as s cubed minus 1 cube because 1 cube still gives you 1. If I work on this, now I will correspond s cubed a cube minus 1 cube b cube. That is to say, a gives you x, b gives you 1. My answer, if I express this becomes, if I express s cubed minus 1 cube, I'll have this expression. Which include x. That's this a is x, b is 1. That gives you x minus 1 into this gives you a squared. That's x squared plus x into 1 because x, of course, a is x and b is 1. So a and x, that's x and 1 plus b, of course, is 1. That gives you 1 squared. Working on this gives you x minus 1 into x squared plus x plus 1. Right. So on expanding x cubed minus 1, I have x minus 1 into x squared plus x minus 1. For this one here, I have x squared minus 1. I can write this as x squared minus 1 squared because 1 squared still gives you 1. In other words, if I have x squared minus 1 squared, this man can be written as x plus 1 into x minus 1, right? So it means that I'll bring back my limit. So the limit at x tends to 1, so the limit as x tends to 1 or approaches 1 gives you x cubed minus 1 is now what? is now x minus 1 into what there? X squared minus plus x plus 1. That's for numerator. All over denominator. That gives you x squared minus 1. And that gives you x plus 1. That's this. Then this s minus 1. This is how you solve this, please. So check it out, please. So know these things here on your memory. Have them on your memory, right? Very important. This cancel this. What am I having left? I'm having x squared plus x minus 1 all over x plus 1. We set the limit as x approaches 1. That is, anywhere I see x, put 1. I'll have 1 squared plus 1 minus 1 all over 1 plus 1. Plus 1 will cancel minus 1. Leaving me with what there? 1 squared over 1 plus 1. 1 squared gives you 1. 1 plus 1 gives you 2. It means that my final answer becomes 1 over 2. That is solve problem of this nature, as you can see on the board. So that is solve problems. Please, the key take here is these three things. 1, 2, 3. Very, very important. That a cube minus b cube gives you a minus b into a squared plus ab plus b squared. Also, I have a cube plus b cube. This one gives you a plus b into a squared minus ab minus b squared. Similarly, I have a square minus b square. It gives you a plus b and of course a minus b. I'll give you the sixth example as an assignment. So take the sixth question as an assignment and leave your answer in the comment section of this video. So take that last assignment, take the last question as your assignment. Leave your answer to that assignment in the comment section of this video. So I'll reply you if you are wrong or correct in the comment section of this video, right? So let's get out what question is 6. Let's look at the question. Question 6. All right, so this becomes your assignment. So I've solved something of this nature in a previous example. It's just that one is your own root, is a denominator. Now, just as what denominator, the same procedure applies, right? The same thing I did applies here too. So go and rewatch that video properly and see the way I did it. Apply the same analogy to this one here. You get your answer. So leave your answer in the comment section of this video to this question 6, right? So I'll see you guys in the next class. So if your first time here, subscribe to this channel, leave a comment, and share this video to your friends and classmates. Also, if you have a WhatsApp group, WhatsApp community where you have your classmates there, feel free to share this video to those platforms. All right, so you can also assist by reaching out to, so that this video can also reach out to more students globally. See you guys in the next class, and welcome to Excellent Link Academy. In our next video, we'll look at the idea of continuity of a function, right? That's like limit idea. So look at the continuity of a function in our next video. The video to continuity will be, I'll attach it to the playlist of our limits, right? So I said the playlist to our limit course is in the video description. So check there, you see a link to our playlist on limit. But to have full access to calculus itself, I will advise you to join our 200 level channel membership, right? So have access to those exclusive videos. not just one but multiple videos, right? So see you guys in the next class. Welcome to Access Academy once again.